Well, good evening, everyone. I'm glad it's warmed up just a little bit for us, made it easier for people to get here, I'm sure, and pleased to have you here this evening. I suspect we'll have a few more filter in, but since you're here on time, we're going to get started right now and get moving with this. My name is Perry Brown. I'm the Provost and Vice President for Academic Affairs at the University of Montana. And this lecture series is designed to honor faculty members of the University of Montana who generally have won some award, been nominated for some really prestigious award or something like that outside of Montana. And we seldom get the opportunity to honor these people at home. And so one of the things we try to do with this lecture series is when somebody has won a very prestigious award or been nominated for one of the highest awards in their profession, we try to honor them here at home and celebrate a little bit with them. And I'm not going to introduce our speaker tonight. Dean Comer is going to do that, but I just say it's just a pleasure to have Joel Berger here with us, and so that he can share with all of us the kinds of things that are on the screen right there right now and what happens with wildlife when they encounter those things up there. So anyway, this is the last of the Provost Distinguished Lectures for this year. We'll have another series again in the fall of next year. So without any further talking on my part, I'll ask Dean Comer to come forward and introduce our speaker for tonight.
Thanks, Perry. And thanks for doing this series. This is a great opportunity for us to get to know our colleagues better. It's really a wonderful thing. Provost mentioned the weather outside. I'm glad to see so many people made it here. You'll be glad to know that one of the themes tonight from the talk is going to be what's happening on the cold Tibetan Himalayas and the American West. So perfect environment to be talking about tonight. Joel, as many of you know, is a professor in Division of Biological Sciences. He's also a professor in the Wildlife Biology program in the College of Forestry and Conservation. And he occupies the very prestigious John J. Craighead Chair. You may know from the announcement that went around, if you saw it, that he did his graduate work in Colorado. He's worked for a time at the National Zoo. And he studies large mammals, and he focuses on their interactions with the environment, but always with an eye towards what's going to lead to conservation and preservation of that habitat. As the Provost said, he recently received a Lifetime Achievement Award from the Society of Conservation Biology, the American Society of Mammalogists, and is an elected fellow of the American Association of the Advancement of Sciences. And he's been working to save animals in their habitats, and that happens to require significant international travel. So when I was talking with Joel before this talk, he told me about a number of stories that came up. I don't know if he'll be able to get to all of them tonight. One of them included fleeing armed rebels in Sudan. I didn't get the details on that. Another one had to do with getting into a fight with the security personnel at the Beijing airport. The reason was they wanted to confiscate his Swiss Army knife. It turned out his Swiss Army knife was in his checked bags, not on his person. So he called the Beijing police on the TSA equivalent and wanted them arrested for stealing his knife, and Joel won the flight. He got on his flight and he kept his knife. It just goes to show you, don't ever try to separate a Montanan from his pocket knife. That's a very dangerous thing to do. But on a scholarly note, Joel is sort of the epitome of somebody who does fantastic field work. He's a great scholar at the same time. He's published numerous articles, 5 books. And his topic tonight, you can see it up there, is In the Pavilion of Snow Oxen, Big Animals in an Increasingly Peopled World. And I'm just proud to say that Joel's a colleague of mine and a good friend. So please welcome Joel Berger.
It's great to be here, and it truly is great to be here. I'm going to make a request. Can we kill these lights or turn them way down, please? Good, thanks. I'm going to ask a question. If you know who Bruce Cockburn is, raise your hand. Okay. For those of you who don't, Bruce Cockburn is a Canadian folk singer. And he had lyrics to one of his songs, and it says something to the effect, goes this way: if a tree falls in the forest and there's no one there to hear it, did it fall? And we can obviously go and check and figure out if it fell. So, if we have a species that is extant and it has gone extinct, how do we know it's gone extinct? Let's do one more. If we have a species that hasn't been named and it goes extinct, did it really go extinct? And what I'm going to do today is to talk about uncertainty, but the uncertainty that accompanies when we do conservation. And I'm going to start with snow oxen, and because many of you may not know what snow oxen are, I'm going to give you a little tour. Snow oxen. They occur in thick forests, sometimes down quite low, where tigers prey on them. They occur up to 18,000 feet, where snow leopards may prey on them. This would be the quintessential snow oxen. It's also the national mammal of Bhutan. But that's one kind of snow oxen. There are other kinds. There's this kind. It's called a musk oxen. It produces neither musk, nor is it an oxen, nor are taken. So let's take a look and see where some of these animals are. And once I introduce some of the animals, then I'm going to tell you thematically what I'm going to try to address tonight. So taken occur in places that, as Dean Comer had said, sometimes are difficult to get to, and because they occur in forests, they're hard to see in forests. In China, Myanmar, a tough place to be, Bhutan, Sikkim. But they also go high. What about musk oxen? Well, they also occur in places that are tough to see, tough to get to. Easy to see because they occur in the open, but tough to get to. Greenland, high Arctic islands, a place where Eric Green, who is here, had a nice encounter with a musk oxen once. Also, Arctic Alaska. So let's look at a sketch. Musk oxen, taken. There are other species within what are the goat antelope grouping. Yaks would be pretty distant, but they have some similarities in terms of their bodies. I'll come back to that. We also have some odd species, coral, right below the musk oxen, also saiga. I'll show you a couple pictures of those in a bit. And then here in North America, I'm going to give you a little quiz later and ask you about that. So let's go to the far left of the slides and drop back 15 million years where we have common ancestors. So they all derive from a common ancestor. That's all I'm going to say about evolutionary history. We're going to move forward now 15 million years and subtract 150 and go to a person who wrote the book, Origin of the Species, sailed partway around the world, Charles Darwin. I want to draw your attention to the year at the bottom, 1874. So one of the things that Darwin said, and this was his first record that I could find of him talking about conservation. Essentially, you cut down the forest, we're going to end up losing, in this case, giant tortoises. What was the population then? 1 billion. We had 1 billion people. That was an era, a gilded era, in which we had a lot of discoveries. Discoveries of some pretty sensational and bizarre and odd-looking mammals. Fast forward another 100-some years, and what we've got is the primate equivalent of weevils. We have us with 7 billion. And so what I want to do today is to focus on the two twin challenges that I see that we have if we're interested in thinking about the biological diversity on the planet that supports human life. First is going to be thinking about the one world, one earth concept, and I'm going to talk about people and profit and that intersection in this Venn diagram. And then what I'm going to do is also focused on somewhat of the gorilla, and we're going to talk about climate. And so I want to start at two of the regions that are warming more rapidly than most places on the planet, two of the three poles. And so the Arctic and what's called the third pole, which is the high elevations of Tibet, the Himalayan region, where we have over 40,000 glaciers. It's the third, it's, other than the two poles, it's the place that has the most ice on the planet. And if we look at the two species, at least two of the species that live right below glaciers, right below ice fields, we will see musk oxen and we will see wild yaks. And we know that they show some similarities: luxuriant fur, wool underneath, skirts that drape almost to the ground. We don't know how the changes that are occurring are affecting them, but we know that changes are not only coming, but are there. When we think about high elevation, we think about Arctic. Of course, there are a lot of similarities because they're all driven by cold weather and ice. And what we're seeing is a decrease in snow cover, changes in permafrost, indirectly consequence of us, but more directly we can look towards mineral extraction, roads, peopleization, oil spills, conspiring together that are affecting and causing ecosystem changes in state. We have to remember that conservation was born as a crisis discipline. And what we do, unfortunately, as a society, is I think that we have a culture that looks backwards. Where are the last pandas? Where are the last tigers? Where are the last 50 best places to go? We even hear from Montana, the last best place. Okay, maybe that one is true. But, you know, somehow we're looking backwards in some arenas. So what I'm going to do today is I'm going to paint three different vignettes. And I'm going to talk about issues in endangered species in the Himalayan and Tibetan region. I'm going to shift to the edge of the continent and focus on species at the edge of its range. And then I'm going to bring this closer to home and focus on something in our backyard. And I'm going to cross three areas as I'm doing this. I'm going to talk about research. I'm going to talk about icy boots, because these places tend to be icy. And then we're going to talk about how we bring some of our research and some of our findings into a societal realm. So, three vignettes. I'm going to start at the edge and go to the Chukchi Sea, and along the edge we have musk oxen. So one of the kind of metaphorical snow oxen that I introduced early on. I'm going to focus on a question, and the question is this: to what extent is climate or something else potentially driving persistence? And we'll focus on this region called Beringia, which is where the Bering Land Bridge was, where Asia and North America connected. So let me introduce a little bit of species background. Most of us don't know much about muskox. So if you look closely in the center, you're going to see some muskox on a slope. And there they are. Their closest relative in North America would be what? Somebody heard me lecture before. Yes. Mountain goats are the closest relative to what we have. So muskox, part of this goat antelope. You know, we see pictures of muskox on Arctic tundra, but when given opportunities, they like mountains. Okay, we can tell by looking at a map, they're probably not going to do well in warm weather. They're Arctic for a reason. Physiological studies that have been done certainly show that they have issues dealing with heat. Muskox used to occur with woolly mammoths. Woolly mammoths are related to elephants, of course. Elephants live in protective groups that they will defend against intruders. Muskoxen do the same. So you've got a couple of males in there and a female. Here what the young ones look like. These are 1-year-olds in a heat fog. Male on the far left, male on the far right. All groups have males that associate with them. And then possible predators in the system are what we call grizzly bears, of course, in Asia. Same species, but they're called brown bears, wolves. And there's been one documented case of a polar bear preying on a muskox, and that was about 120 years ago. Okay, so what I want to do is introduce a little bit about the study regions and then tell you where I'm going to go. And I will point out 3 vignettes. First vignette is going to be a mix between pretty pictures and slides and a little bit of data, just a tiny bit. Second vignette will have mostly pictures and a story to tell, and third vignette will have some maps and some pictures. And so this is not all going to be data heavy, and I know that'll really disappoint you. All right. So 3 populations, A, B, and C. This is what we know about A, B, and C. A is increasing, B is not, and C has been toasted. So this information comes across 30 to 40 years. Bering Land Bridge, Cape Thompson, Arctic Refuge. Arctic Refuge has received a lot of attention. That population there has gone from over 400 down to about 10 animals over about a 15-year period. So it's pretty much defunct. So again, the question is going to be, why do populations vary? What are the drivers of the variation in A and B? We work Bering Land Bridge. So this is when the ocean comes up about 100 meters, so not very deep. Russia and the U.S. Sarah Palin's view was not off if we go back a few thousand years. She could actually maybe see it. Okay, second study area, Cape Thompson. So 2 study areas. A little bit of cowboy biology. We've captured over 200 animals. And in doing so, for 4 years, I worked with Lane Adams, and Lane's a biologist up in Alaska, and so we take physiological measures, we weigh animals, we check their teeth. We also have gone, in particular at my urging for the last 3 years and now across 7, non-invasive approaches in which we collect poop samples. From the poop samples, we're able to ask, are pregnancy rates associated with these different demographics? Are stress hormones related with these different demographics? And so we're also doing photo estimation. And so up in the top right is the typical tepid late winter sky, herd of muskox on the bottom right, and an individual approaching to get photos. The reason we approach to get photos is that we can measure head sizes. And so we can do this for every individual. We're interested in animals before they hit puberty, so up until about 4 years of age. We can use growth rates of individuals as a marker for their nutrition. And we know this because we've worked with muskoxen on farms, feeding them different foods, and then we can measure their sizes. And so we've done this for about 700 animals, which is a really, I think, a good way to approach it, because it means we don't have to play cowboy biologist and harass them all the time with helicopters. Now we can just take photos. Sounds easy. I'm going to show you what it's like to do this in the field. So I'm going to give you a short little video here. The lasers we use don't work well in wind like this, and so we have problems and have to go back on different days when we get these kind of storms that go forever. Okay, so the point here is 2 different populations, one's increasing, one's not. A word about what will be coming. I'm going to just reflect and show you the gray and the white. The gray will be for the population not increasing, and so you'll see some data that look like this. But as I said, you're not going to get much data. This is probably the last chunk. So work with Fred Goodhope Jr. Fred's lives in one of the Chukchi Sea villages. He's kept our snow machines working for 7 years. And as we go out, we're measuring head sizes, summing up stress hormones, pregnancy, looking at annual growth rates, and measuring juvenile survival. So we're interested in different hypotheses that are affecting how these populations grow or don't. And so the major hypothesis that I'm just going to talk about, is it food? We know that climate affects vegetation. Vegetation is what muskox eat. So to what extent is nutrition constraining the population that's not growing? If food is a constraint, we expect certain things to happen. A population that is not growing fast should be smaller in size. They should be in poor body condition. Their body sizes might be less, and their pregnancy rates would not be as high. So let's take a look at this. On the left are the measures. Let's look at the contrast and see what direction we go. So juvenile size, no differences across 7 years. No differences. Adult mass. 1 of 4 years we had differences. Okay, 1 of 4. Pregnancy, nothing. Stress hormones, nothing. So is food limiting? We can't say with impunity no, but we think probably not. What else might be going on? Let's look at adult survival. Top left picture is a radio collar. It's been shredded. It's fair to say that this animal probably did not die a peaceful death. The bear in the lower left is on top of a muskox that it had buried. So predation. But when we look at survival in our two populations, no differences. Okay, so maybe not predation on adults. Juvenile recruitment. Well, when we look at that, and remember, drawing your attention to the gray versus the white, pretty striking differences, large and consistent. Okay, so maybe a smoking gun there. If you don't have recruitment, you're not going to have a population that grows. What are the factors that are contributing? I'm going to draw your attention to the two on the left, to grizzly bears and to the human, and look at a possible interaction between the two. With human harvest, we have an asymmetry in sex ratio. In other words, if we're taking more bulls, then there's going to be a greater difference in populations, or maybe with herd structure. And so there could be an effect of bulls that affect social structure or juvenile recruitment. And so I'll draw that question mark there, and let's think about how that might work. So male on your left, female on the right. And so if we are taking more bulls, we can suggest, make a suggestion, make a supposition. If males are playing a role in group defense against grizzly bears, we're going to predict that maybe the behavior in groups with and without bulls is going to affect their ability to thwart predation. So how can we do that? These areas are a lot larger than Serengeti. They're a lot larger than Yellowstone. We can't go out and wait and watch for interactions. But what we can do is we can use models. We can construct models, which we've done. We've done this in the subarctic and the boreal using a fake moose to understand how this works. Other people have done it by making fake lions in Serengeti and looking at their manes and going out and trying to understand interactions with manes that vary in size and color. And so how do we go out and test responses to bears? Uh-oh, and Perry's smiling. I think he knows where this one's going. Excuse me, Provost Brown. We do use a fake bear, yes. And so here, muskox, almost out towards the pack ice. Here we are doing a presentation. And we actually do this with a lot of seriousness because we want to get to the bottom of this, and we try to have fun, but it's cold, so it's not always fun. We use a caribou because we need control, and so our caribou is our control. And we actually do this across years in different geographies. Now, I don't have the results yet because it's slow going, and so Provost Brown will have to invite me back in a couple of years. All right, so let me just sum up. Climate or something else. At this point, we have no evidence for food limitation in this system. Had we focused only using remote sensing and not been on the ground, we would have missed opportunities about sex ratios, understanding recruitment, understanding the potential for interactions, which is where we continue to go at this point. And despite its remoteness, it seems as if there could be a human role. And so trying to pull this back under this umbrella, working at the edge of a continent, doing research, being on the ground. Beringia. We've been working on the Alaskan side. Here's Wrangel Island over on the Russian side. The video that I showed you was from Wrangel Island, where we spent 2.5 months this winter. Despite Ukraine, despite Crimea, the Russian government was fine with having an American scientist there. And when we look at opportunities there, we have predicted Wrangel as a climate refugia because it's not warming nearly to the same extent. And there's also the possibility of a novel predator-prey system there. And so you've got muskox on the ground. Muskox is the little dots up on the hill, and obviously a polar bear. And you know, our ability to get detailed data on these interactions is limited, but so far we've documented 3 cases of predation by polar bears on muskox. Polar bears are on land more, and so we may be seeing a new dynamic. But also the opportunity is not just to do the science on it, but this was an op-ed that we published when we got back and ran it past the Russians, but not for their approval. We just gave them a heads up because we have opportunities to continue to work to promote science in the name of conservation, and they're willing and we're willing. I'm going to shift gears, and we're going to move to a more crowded playing field. The Arctic is remote. We're going to go to a different spot, and we're going to look at some questions about globalization and economies and people. More people, more complexity. And we're going to look at 2 countries. We're going to focus US. We're going to focus China. Similarities, obviously, over on the eastern side, eastern seaboards, more populated areas as you go west, drier, more mountains, less crowded. Total area, very similar between China and the US. China with 4 times as many people, a density that is approximately similar. But notice that China has 10 times as many cities, more than 10 times than we do with a million people. Their densities are relatively higher. They also have landscapes that are far less peopled. Crowds in the east, open space in the west. Ecological surrogates in terms of species. They have chiru on the top. We have pronghorn on the bottom. The question that I want to address is this. How do our cultural preferences in the West, how do they affect biodiversity far from where we are? And I'm going to do this by focusing in different areas. Tibetan Plateau, India, and Mongolia. And so the Gobi Desert is not part of the Tibetan Plateau, it's north. It's Gobi. It's between Siberia and Tibet, but also Tibetan Plateau. Again, the question that I'm going to ask about deals with Western cultures and effects, but I'm going to start here on the right with species, move to landscapes, and move to people. So the little map reflects 6 of our study areas, protected areas, but I want to introduce the species. And so again, keeping in mind, I'm going to come back to this Venn diagram, people and profit. So collaborators, Ai Kong, who's a Tibetan scholar. She visited here for 2.5 months, sponsored in part by Department of Geography with Sarah Halverson's help. and then our programs and some NGO outside support. Bouvet Badr from Mongolia, and then Charu Mishra from India. Traditional Asia is this: camels, yaks, domestic species playing an important role in people's lives and economies, as do goats. 100 years ago, Cecil Rawlins, who is a British military officer, visited the Tibetan plateau, and he talked about high elevations and made the comment that animals were kept there so that their wool would be as thick and as profuse as possible. And I want to thank Wes Sarmento for one of his photos here. There will be another one. Here's the important point about Rawlins' quote, is that Pasham can be found as pashmina in any kind of chic stores in Southern Asia. It can be found over in Italy. It's called cashmere, the billion-dollar cashmere industry. Now, 90% of the world's cashmere comes out of two countries, China, Mongolia. 90%. If consumerism is impacting biodiversity in Central Asia, several different conditions have to be met. These would be products are imported to the West. There are some sort of benefits, incentivization for the people who make the cashmere available, that the goat increase exceeds that of other livestock, and that there are negative effects. So let's talk about these, and let's focus on nuance, in other words, some details, and I want to draw your attention first and introduce the landscapes and the species. And so we have here in the Gobi Desert, Altai Mountains, it's arid like the American West. A few little dots along the river off on the left would be what in Mongolia are called gers, what in Russia are called yurts. Usually we call them yurts here. This is a saiga. It really does have a proboscis like that. There it is. It's the world's most northern antelope. Remarkably, they occurred in Alaska, roaming with muskoxen and mammoths. Saiga in their natural landscape below the Sutai Glacier, Mongolia's most southern, but this is what Alaska looked like when they occurred there. And we've had a project for 6 years there, and we're continuing some in a supervisory role in Mongolia with saiga. Okay, other species. Tibetan Plateau, this picture is at about 16,600 feet. These are called kiang. Kiang are an endangered species, half horse, half ass, called a hemione, but it's not a hybrid. It's a native wild species, endangered. They're wild yaks. Top left picture shows them living below the margins of glaciers, an endangered species. Some 14 million in the world that are domestic, about 10,000 in the wild that are wild yak. These are charu. It's an Alaskan-like setting. They're also an endangered species. This picture at about 15,000 feet. Blue sheep. Blue sheep are the major prey of yet another endangered species, the iconic snow leopard. Tibetan gazelles, they're far more common. They would be more like our mule deer. But then 4 other endangered species, Bactrian camels, the wild form, Hulan, which is wild ass from the Gobi Desert, Taki, also known to some folks as Przewalski horses, and then Przewalski gazelles. Bringing this back just to remind you where I'm going to address these issues about localized impacts from importation of products, but let's talk about local people. People live on the land. People have lifestyles. Their lifestyles are reliant on their pastoral animals. In so many parts of the world, every part of the world, change comes. Sometimes conflict comes with it, whereas horses and yaks were beasts of burden and used in a lot of different ways. We now have motorcycles, we have more cars, automobiles, trucks coming into these systems. And if we look at the consequences of the shift, what I want to do is portray 4 decades, and again, a Sarmento photo here, thank you, Wesley. And what we see both for Ladakh, so in northwestern India, as well as across Mongolia, what we have is about a 3 to 5-fold increase in goats. So what's the relative abundance of the native species that I've been talking about in these protected areas? So here's the spectrum of species that I've introduced. Let's look at how they fare. So in black are going to be the native species. The stippled will be the livestock. They're the native species. I'll draw your attention to the black. What we have is that the native species in these protected areas are about 5% of the total. So possibly some pretty severe impacts. Here's an example of domestic trailing in the Altai region. Also, some snow leopard tracks. And so I'm going to give you a test just to kind of break this up a little bit. I'm going to ask you to find the snow leopard in this picture. And it's almost impossible, so I'll give you a hint. It's going to look like that. And I'm going to give you another hint. It's in the left upper quadrant. Left upper quadrant. I'm going to circle it. And for those in the back, I'll highlight it a little bit better. All right, well, here's my point. More livestock, more conflict. And so I can summarize where we're at by looking at the intensification of ecological effects. Food overlap, native species being displaced to other areas, changes in vital rates, reproductive rates, dog-associated predation, because with herders come dogs, decreased feeding times, and, of course, retaliation, just like we see here. So I'll just draw your attention to one, dog-associated predation. This is what happens. And this was a paper that a postdoc of mine, Julie Young, some of you may remember her, she and I and a number of others published this about 3 years ago. But yeah, so some pretty gruesome effects. So what do you think is missing? What's missing from this are people. Not so much the people, but yeah, people live here and people have livelihoods too. We've got this global chain link, consumption of cashmere, people on landscapes, different kind of values, huge incentives for the herders. When we adjust the consumer price index and we look at what their profiteering margins are relative to other forms, they're doing great by marketing cashmere. There's incentives for doing it. And so what we've got is not a food web, but we've got this kind of economic, ecological, conservation complicating web. When I was in Santa Fe earlier this year, you could find cashmere pretty cheaply. So would we expect herders who are living in places like this, why would we expect herders to really be motivated by what we, or even international, or even government agreements are when they're eking out a living? And I think that the answer is obvious, or obvious to me anyway. We shouldn't expect them to care. I don't expect them to care. So how do we move beyond the biological realm to try to do something differently? Because clearly the issue is not in the biological realm, it's in a social realm. And so just a quick snippet. My colleagues and I have worked locally in Western Mongolia, and we've brought in not just herders, but we've brought in police, we've brought in military, we've brought in Mongolian Academy of Science scientists and economists to try to figure out what the people from the ground level want. And then we're going to worry at the next level. And so at this first level, we've been talking about different kinds of options. These would be, camel wool, which certainly doesn't have the attractability that cashmere does. UK is now marketing what's called black yak in chic stores. So there's a beginning. We've been trying to target consumers in London and Paris and in New York, also in Italy. And we've been doing this with op-eds. This one that we wrote was during Fashion Week in New York. The journal Nature has done a little bit of feature of our work on that, and then we've had The Guardian involved, and then we've continue. But our next series of workshops are going to, again, continue to focus at a higher level and just see what we think might be optimal and then go back. So what I've tried to do in this vignette is to talk about different regions, different societies, how we view things. Not necessarily with a solution at this point, but recognizing that there's a problem. Final vignette. I want to move this to the world's third most populous country, here. And I want to talk about a phenomena that is being challenged, long-distance migration. And we know that this is an issue whether we're dealing with species that rely on aquatic mediums, whether it's streams and rivers or oceans, whether they're aerial or whether they're on land. And I want to focus on land, and I want to focus on species that move beyond borders. And I'm going to take a species from our backyard, pronghorn, and the setting is going to be the Yellowstone ecosystem, and in particular a little bit to the south, Grand Teton National Park. And so here are bison, here are pronghorn, and I'll set the stage with an explicit example of the issue. So if we go back 75 years ago, the black lines on there are migration routes into and out of the Yellowstone system. Today, we have one in the top left corner that's about gone, so only one is really remaining. We gave it a name, the moniker Path of the Pronghorn, because it allows at least people in that system to know the species and to know the area we're talking about. So that gives us some context. Our challenge was, how do we protect this last critical corridor? And why is it relevant? Well, I'll tell you why it's relevant. If we lose it, Grand Teton loses one more large mammal. Okay, so that's one national park. But in the US, you have 300 million people a year that go to national parks. You have about 300 million people a year who go to professional baseball, football, and basketball combined. Obviously, national parks don't have the cachet that professional sports do. But people care about parks. People care about seeing wildlife in parks. We don't want to lose this corridor. And so to understand migration, we got involved in some research. Again, we were doing helicopters, and we were radio collaring animals, GPS collars, and we were going to let the animals define their route. And so where the blue line starts in the top left, that's about where the national park ends. So most of the area that these animals use are beyond the parks. The parks don't have the capacity to do anything because they don't have the statutory authority. And the animals have a challenge. The challenge is topographic. So this is what we called the Red Hills bottleneck. Every single animal that goes into and out of Grand Teton goes through this box that is less than 2 football fields wide. Every single animal. They motor across the surfaces and the cliffs, and they go over hydrographic divides. And nobody thinks about pronghorn, nobody, as a species that will use forest, but they do, to get to where they're going. So if we block any of these routes, they're toast. And so what we have is a 120-mile one-way corridor. It's the longest in the US. It's a historic corridor. We know it's been used for 6,000 years from archaeological digs. Again, longest in the lower US. Complex array. How do you do conservation outside parks when you have Fire Service land, when you have the hallmark of, one of the hallmarks of being an American, ownership of your own land, and then you have BLM lands. So it's a complicated array. To try to garner some cachet locally and broader, we pointed out that not only is this the longest migration by a terrestrial mammal in the lower US, but for any mammal, land mammal, between Tierra del Fuego and the Canadian border, nothing migrates further than the pronghorn in this area of Wyoming. Our approach was to build support, to work with county commissioners, The science played a role. It was a small role. It was an important role. Publishing helped us get to the table. People recognize that science plays a role. We also worked with local media. We worked with national media. We did op-eds again, some in the New York Times, some in local papers. Worked with the business communities to celebrate the return of the pronghorn. Worked with chambers of commerce, county commissioners who wrote letters to the governor. Worked with professional societies like American Society of Mammalogists. Met with the governor, and that's one of the beautiful things about living in the West, where you can have access to governors at times. And so Governor Freudenthal was the head of the Western Governors Association, and he did something, accomplished something unprecedented, unanimous support for referendum. It was toothless, but it put protecting migration corridors on everybody's agenda. And about a year and a half later, the ancient pronghorn path became America's first wildlife migration corridor. And Dirk Kempthorne, who was then Secretary of Interior under the George W. Bush administration, demonstrated why bipartisan participation works, as opposed to some of the things that we see today. Park Service established a migratory species program. Nat Geo did a feature. More than 50 million people read Nat Geo. The beauty is it can lead to inspiration. It allows people to dream. I know when I was a kid, I read it. I know Nat Geo still has a pretty good extension. And so when you think about dreams and you think about roads and you think about underpasses, the state of Wyoming invested $10 million to build one for pronghorn. And if you look carefully here at the underpass, I'm going to draw your attention to the overpass, because they built the world's first overpass for an open plains-dwelling species. And just like in the movie Field of Dreams with Kevin Costner, who said, "Build it, they will come," Wyoming built it, and they came. So the point is that we can take science to conservation, but conservation is people, and we have to shape people. We have to work with people. Some folks become pessimistic about looking ahead. I think about inspiration, and I think about action. So here's a panda, and the panda is eating a takin. At the Beijing Olympics, do you know what the mascot was? It was not a panda. It was a churu. And we know that churu and pronghorn can carry some messaging with the public. And so when I think optimism, I think, if Wyoming can achieve something like Path of the Pronghorn, we have to be able to use other models for other successes. When we think about protected areas, and we think about China, when George Schaller, who many of you may know of, he and I and Mark Hebel-White are all colleagues on papers together, and Schaller said that when he worked in China 3 decades ago and he used the word conservation, people's eyes would glaze over. They didn't know what it meant. Well, what it means today is an area the size of California that is protected. I mean, Chinese protected areas differ in philosophy than ours, but we've got some huge successes. If you look in southern Africa, there's an area that is part of the Kavango-Zambezi system. 5 countries have come together to create and to unite 36 reserves. So there are things to be thinking about. Now today I use snow oxen as a metaphor for remote, for species at the edge where environmental factors are probably limiting their abilities. And so trying to understand that. Species at the edge and climate. Here's a goral. I told you there was one species that you hadn't seen, and so at some other point I will talk about them. So I guess one of my major points today is it doesn't matter where we work, it matters how we work and what we achieve. I pick remote areas because sometimes there are, I'll say this differently. In the US, in many areas, we have 20 biologists for every species. In these other places, you might have 20 species for every biologist. So, summing up, some groundwork is good. Research is, of course, good. Involving society and trying to inspire society is a good thing. I started with Darwin. I talked about giant tortoises. For some people, Darwin and Alfred Russel Wallace are heroes. They're pretty high up on my list. But the true heroes are those in the classroom that don't get the credit, that are working with the next generation. And if we think that we want a chance, obviously, and I know I'm talking to an audience that believes the same thing, but an educated public is important. And education's expensive. But if we try the converse and try ignorance, then we would really have a good experiment. So when I ask, somewhat rhetorically at the beginning, about the tree in the forest, I'm going to leave it for you to tell me if conservation is working. I've had lots and lots of help, and I think we can we do questions? Yes. Yeah, okay. So thanks very much. And we can turn up some lights, please. Thanks.
Yeah, what seems to be the story with the musk oxen Arctic National Wildlife Refuge?
Okay, I'll repeat that. What was the story with the collapse of muskox on Arctic Wildlife Refuge? Yeah, so for about 25 years they were doing pretty good. And there's always been a little bit of hunting that's allowed there because it's not a national park, it's a wildlife refuge. It's not totally clear why predators became successful, but based on some of the people who I've talked with who've worked up there, suggest that a few very bold brown bears, grizzly bears, figured out how to penetrate the system and were very, very successful. But at the same time, it's just not predation because the animals started to disperse further and further and further, and their pregnancy rates were suspected to be dropping. And it was thought that there was a food limitation. So like in so many systems where you've got factors at one level, you've got factors at another level. And so despite it being Arctic National Wildlife Refuge, hugely visible, fair amount of money, there was never a single cause.
Yes.
Is the Gobi grizzly a factor in predation, or you didn't mention just...
Okay, so Gobi Desert is very dry. It's a lot like the Mojave Desert, if any of you have been over driving around Las Vegas over to LA or those areas. So that kind of habitat sustains a population of between 25 and 40 grizzly bears, called brown bears there, or Gobi bears. And they're pretty good vegetarians, and they make most of their living that way because they don't have much in the way. I mean, bears generally are omnivorous. In certain cases in North America, they're certainly good predators on their own. But they're hanging on. They seem to be sometimes not so good, but they receive a fair amount of protection.
When you're talking about the musk oxen and how people are indirectly affecting, will that apply to other species as well?
Okay, so the question was, I'm going to paraphrase, and I hope I get this right. For the musk oxen, where we have a situation where there may be some indirect effects of hunting, removing the males, the question I think then is does that apply also to other species? Muskox are really unique for a North American mammal. You don't see defense structures like that in a North American herbivore. I mean, certainly wolves and packs are very defensive of pack mates, but the more direct answer to your question, for like big game hunting, you don't have situations where you have an entire herd that's banded and bonded together for protection. So no, it probably doesn't apply to other species, at least on this continent.
Where?
I was curious, the Path of the Pronghorn was such a major success when you're talking about all the different groups that you had to get to work together. I was curious that, even though it was such a huge success, who was the hardest to kind of get on board? I don't know if you can pinpoint that, but out of the different groups of people.
So I'm being filmed, and so this will be some sort of a PBS thing, and I will answer very directly. I'll be very direct. The hardest part were the people. Let's see. So the county south of the Tetons is called Sublette County. Sublette County has been not used to NGOs. Not very accustomed to people with long hair and not having cowboy hats. Working with the county commissioners was pretty good. They were interested. They wanted to hear the story. They weren't convinced. And we continued to work with them and work with them. We held workshops. We had public meetings. We invited every diverse array. We brought in professional facilitators that had nothing to do with conservation and we asked, where's their common ground? Do you care if these disappear? And it's like, been here 5 generations. They're always going to be here. But when we started to point out how unique what they had in their backyard was for the entire new world, South America and North America, it started to gain some resonance.
Maybe one more? We got it? If not? Yeah, right here. Jackie.
So much of your communication seems to be focused on the media, which normally we consider to be a marketing function. So would you say that training in marketing and media relations for your biologists in your program would maybe be beneficial?
Ooh, I have to ask my deans for permission to answer that one.
I'm just really surprised at how prominent the public relations part of your work is. It's taken me by surprise.
So, here's the deal. I was very lucky to be standing here as the Craighead Chair. So my position is slightly different than just doing only science. I get to do a number of other things. And so when you want to communicate your science, they don't care about your publications. They want to hear from the person on the ground who's been doing this stuff. And so in a different life, when I was not at a university, all this was hugely important. And it's still important. And it's not just for me, because I stand here, but I think every one of our graduates has to be able to be articulate and to think on their feet and to be able to work across different arenas, of course. Now, I think your question, I'm not sure if your question was, should scientists specifically, but yeah, everybody has to. That's why we get degrees, right? I'm talking to you. You know that. Yeah. Okay.
Well, why don't you join me and just thank Joel very much for the delightful